So here's some more notes on section 2.1, and this is on theorem 3, and this is over on page 64. So if you read theorem 3 on page 64, it says f of x, a function f of x has a limit as x approaches c if and only if the right hand and the left hand limits exist at c and that are equal. So you want to read that, and let's just take a look at this graphic example of what we're talking about. And I wrote some different possible situations. Let's look at what happens as x approaches 1. Now, as x approaches 1 from the left side, what's the limit going to be? Well, my vertical position gets closer and closer to 1. So as x approaches 1 from the left, or the left-hand limit, that would be 1. But as x approaches 1 from the right, it's approaching a vertical position of 2, so the right-hand limit is 2. So what's the limit as x approaches 1? Is it 1 or is it 2? Well, we can't make up our mind. That's actually neither. It does not exist because the left limit doesn't equal the right limit. So we would say that the limit does not exist. All right? So we have a left limit, a right limit, but if they're not the same, the limit does not exist. Does the function have a value at 1? What is f of 1? Well, no, I don't have any values over here, so f of 1 does not exist. Okay, let's take a look at what's happening around 2. Well, the limit as x approaches 2 from the left is going to be, it looks like it's coming down to 1, the vertical position. And the limit as x approaches 2 from the right, it looks like it's going up to a vertical position of 1. Well, is the left limit equal to the right limit? It sure is. So we say that the limit as x approaches 2 is actually 1. Okay? And I didn't get a chance to do this, but let me put a value in here. And what is f of 2? Well, the way I define it like this looks like this is 1 and 1/2, or 1.5, right between 1 and 2. So actually the value of the function doesn't have to be equal to the limit. That's the point I wanted to make. So in this case, it would be 1.5. So the left limit, the right limit exist. They're the same. So the limit exists at 2 without the plus or minus signs. But the value of the function doesn't have to be the limit. In this case, it's 1.5. Here it didn't exist, but the limit didn't exist either. All right, let's take a look at one more point, 3. And what's the limit as x approaches 3 from the left? It looks like it's going to be 1/2. And as x approaches 3 from the right, looks like it's coming down to 1/2 also. So the left limit and the right limit are both equal to 1/2, so they're equal to each other. So the limit as x approaches 3 is just 1/2. And what is f of 3? Well, we have a point there, and that's also 1/2, so all the answers are the same. Okay? So this will maybe help you on your definition of a limit existing and your two-sided limits, your left hand and your right hand limits, okay? And that's basically what theorem 3 is talking about, okay? Hope that makes sense.